Okay, welcome to the AQA Level 2 Further Maths 2022 Paper 1 walkthrough. Alright, question number 1. Increasing something by 20%, we're going to multiply it by 1.2. So we'll take an x plus 1 multiplied by 1.2 and equate that to x plus 6. Expanding out the left-hand side, and then bring the x terms onto the left and the non-x terms onto the right, divide by 0.2, and we get x to be 24. Question number 2, so we're given a gradient and a straight line. I'm going to jump in using the y minus y1 equals mx minus x1 formula. Plugging in x to be negative 6, y to be negative 4, the gradient is 3 over 2. We want to find where that line crosses the y-axis, so I'm going to substitute x equals 0 in there, and that will leave me with y plus 4 is equal to 9. Therefore y is 5, so the point's 0, 5. Question number 3, well, that first section from 0 to 1 is the line y equals 4 minus x, and then we get a quadratic between 1 and 4. I've calculated individual values of x and just plotted those, and then we have a straight line for the bit on the left, the parabolic shape for the section in the middle, and then a straight line. Yours will be tidier than mine because you'll have used a ruler. Should look something like that. To find g inverse of x, this is a very straightforward question. X equals 6 minus 3y. We're going to make y the subject. I brought the 3y onto the left and then divided by 3. Anyway, 6 minus x over 3 for that one. Okay, question number 4. Tan 30 is going to be root 3 over 3 or 1 over root 3, whichever one you prefer. Squaring that is going to give us a third. If you forget your common trig values, you can draw a little triangle. As you can see there, I've got an equilateral triangle with side lengths of 2, and I've split it up into 2 separate sides. The angle will be 30 at the top. Using Pythagoras, you can get the root 3, and you can see that tan of 30 is going to be 1 over root 3, which when you actualize the denominator is root 3 over 3, or you can have just, if you've just memorized that, that's absolutely fine. Squaring root 3 over 3 gives you a third. For cos x, cos of 0 is 1, cos of 90 is 0, cos of 180 is minus 1, cos of 270 is 0, and cos of 360 is 1, and that gives you the cosine shape, which I've poorly drawn in there. There you go. Question number 5. So we've got a factorized quadratic and then the expanded quadratic written as an identity. I'm going to expand out the quadratic on the left-hand side and then equate coefficients. So expanding it out, and then I'm going to factorize an x out of the middle 2. I write the x at the end just because it's nice to have the the coefficient in front of the x there. And we know that that's equivalent to 15x squared minus 2x plus b. Obviously the x squared coefficients already match, so we can match up the x coefficients. So 5a minus 12 on the left must be equal to the minus 2 on the right. That allows us to solve an equation to find the value of a, which comes out as 2, like that. And then the minus 4a must be equal to b, that's the constant parts at the end. We know that a is 2, so therefore b must be minus 8. For differentiation, well, let's expand it all out so we can get our equation in a form that's easily differentiated. So expanding out, 2x to the 7 plus 4x to the 4 minus 6x cubed, multiplied by the power, subtract 1 from the power, so 14x to the 6 plus 16x cubed minus 18x squared for our differential for 6. Question 7. We've got ourselves a right-angled triangle. So I'm going to draw a little sketch there. So we've got A at minus 1, 5. We've got B at minus 2, 5. So it's directly to the left of A. And we've got C at minus 1 and 5 3/4. So that's directly above A. And that gives us a shape. We can see quite clearly that the right angle is going to be at the point A, giving us a little right angled triangle there. Okay, we want to work out the length of B to C. Well, the base of the triangle is 1, the height of the triangle is 3/4. We can work those out just by comparing the coordinates and using Pythagoras on that. Square root of 1 squared plus 3/4 squared. 3/4 squared is 9/16. 1 squared is obviously 1. Adding 16/16 to 9/16 gives me 25/16. Both are square numbers, so I can square root the numerator and denominator one at a time. Give me 5/4, or 1.25, or 1 1/4, any of those. Okay, question number 8, the matrix multiplication. Question, we know that a 90 degrees anti-clockwise rotation represented as a matrix is 0, -1, 1, 0. We know that a reflection in the line y equals x, essentially just swapping all the x and the y coordinates around, is going to be 0, 1, 1, 0. If you forget these, you can just have a little think about what happens during matrix multiplication, and you clearly see that actually the 0, 1, 1, 0 is going to flip the x and the y coordinates around the other way. Okay, so carrying those out, well, the one we're carrying out first we put on the right hand side, and so we're going to get 0, 1, 1, 0 times by 0 minus 1, 1, 0. Because this is a show that question, I'm actually putting in a bit of detail on the calculation here, showing that I'm carrying out the matrix multiplication in the correct manner. And that comes out as 1, 0, 0, minus 1. For some reason I forgot the minus 1 in the bottom right hand corner there. I'm sure you didn't. And that is a reflection in the x-axis, which is what the question wanted us to do. Question number 9, so quadratic sequence. There's a few ways of doing quadratic sequences questions. Here I'm laying out one of the acceptable methods. So we've got a first difference between the terms there, we've got a second difference between the terms there. So the common second difference is 4. Half the 4 gives me 2, so I'm going to write 2 lots of n squared, where n is the position of each term in the sequence. So that's 2 lots of the square numbers. Let's call the original sequence S, unoriginally S for sequence, and I'm going to subtract that sequence from my new sequence 2n squared. When I do that, 2 take away -2 is 4, 8 take away -1 is 9, and so on, and we're left with the sequence that is 1 less than the 5 times table. So 2n squared minus s is going to be equal to the 5 times table, subtract 1, or 5n minus 1, and then let's make s the subject. Bring s onto the right, subtract 5n, add 1, and we get the original sequence being 2n squared minus 5n plus 1. For 9b, it gives us the nth term of the quadratic sequence being n squared plus 10n. We want to know when is that less than 2000. So let's let n squared plus 10n be less than 2000. This is a quadratic inequality, so I'm going to bring the 2000 onto the left-hand side. I'm going to factorize here. You could have completed the square. You could have used the formula to find our critical values. I've just factorized n plus 50, n minus 40 is less than 0. Obviously n cannot be negative here, so our critical value is less than 40, and therefore that's going to be 39 terms as our value for n. Okay, rationalizing the denominator, so this is just a procedural question. You multiply by its conjugate pair, multiplying by 3 minus root 3 over 3 minus root 3. and we will expand out the top, so root 3 times 3 is 3 root 3, root 3 times negative root 3 is negative 3, and on the denominator, 3 times 3 is 9, root 3 times minus root 3 is minus 3, and the irrational bits cancel, leaves us with 3 root 3 minus 3 all over 6, or if you prefer, root 3 minus 1 over 2, and that's now fully simplified. Question 11, binomial expansion. I'll have a little Pascal's triangle there. You may have learnt Pascal's triangle down that far already. 1, 5, 10, 10, 5, 1 is quite a common line. Then we're just going to substitute each part into the binomial expansion. So starting with 3 to the 5 in decreasing powers of 3, and then increasing powers of 2x. Nice to put the 2x in brackets for each one of those so you don't forget to square or cube or raise the 2 to whatever power it is as well, and then the coefficients of that line of Pascal's triangle at the front, and we get a full expansion there. We now need to expand it and simplify. 3 to the 5 is 3 fourths 3, and each calculation, you can work out each one if you want to by doing each individual calculation, or you can just do it in your head if you're good at mental arithmetic. Anyway, 343 plus 810x plus 1080x squared plus 720x cubed plus 240x to the 4 plus 32x to the 5 is expanded and fully simplified. Question 12, again we're given the nth term of a sequence. It tells us that one of the terms of the sequence is 32 over 11, so I'm just going to equate 3n squared over n squared plus 2 to 32 over 11. I'm going to carry out a cross multiplication, essentially bringing the denominators from one side up onto the right hand side of the other. So 33n squared is equal to 32n squared plus 64. I've expanded the right hand side straight away. N squared equals 64. N must be positive, therefore n is equal to 8. As n tends to infinity, I'm looking at 3n squared divided by n squared, the most powerful part of the sequence, and 3 divided by 1 is 3. So it's going to tend to 3. Okay, question 13, playing about with indices. Y to the negative 2, I'm going to bring that down as a fraction and write it over y squared. And then for the division, I'm going to do quite a big jump here. We would normally have 3x squared over y cubed, but I'm going to flip that and multiply. So y cubed over 3x squared, turn it into a times, and then expand it out. So y cubed cancels with y squared, leaving me with y. 3x cubed divided by, 6x cubed divided by 3x squared is 2x. So 2xy plus 3x cubed y to the 4 for the second one. Question 14, making either subject. First thing, let's multiply by 3. Let's get rid of the fractions. Then I'm going to bring the 5e onto the left-hand side to get all the parts with e onto one side. Therefore, I can factorise out my e and then divide by 3f minus 5. So we'll get e equals 4 over 3f minus 5 for 14. Question 15. So this is a geometric proof question. We are going to hunt down the angles until we get one with the y in it. So starting with what we know, well, we know AB and BP and AC and CP, they are both tangents and radii. And so the angle between them is going to be 90 degrees in both cases. Now we know that ABPC is a quadrilateral, so the angles in that quadrilateral will sum to 360. So if I add my two right angles in X and subtract that from 360, it will find angle BPC. and that simplifies to 180 subtract x. Now for this one, I have added in a couple of extra lines to create a cyclic quadrilateral. So you can pick any point on the circumference, somewhere towards the bottom, and if we join that point up with points B and C, it allows us to use the circle theorem that tells us that the angle at the centre is twice the angle at the circumference. So we know the angle at the centre is 180 subtract x. So the angle at the circumference, that BFC, I've called it F. Of course, you could call it anything you like. That's going to be 180 minus x all over 2, or if you prefer, 90 subtract a half x. Because this is a proof, I have quoted the circle theorems as I've used them. Just gives clarity to whoever is checking your proof. Now, because we have angle BFC and we know that BFCD is a cyclic quadrilateral, opposite angles on a cyclic quadrilateral will sum to 180 degrees. So if I subtract our 90 minus a half x from 180, we will get the opposite angle, the BDC, which is the angle we want, y. So in this case, we're going to 180 subtract 90 lots of a half x, which will be 90 plus x over 2. And the reason is because, of course, opposite angles on a cyclic quadrilateral sum to 180 degrees. I could have put y equals in front of that, which would have been nice, but I forgot. So there we have it. Okay, question 16, simultaneous equations. You have a choice here. You could do this in a number of ways. Essentially, you've got to make x or y the subject of one of the two equations. Here I've made y the subject of the second one by dividing both sides by x. So y equals minus 3x. Substitute that into the first equation. X subtract negative 3 over x will be equal to 19 over 4. Subtracting a negative is the same as adding it on. And then I'm going to multiply everything by x to get rid of the x as the denominator. So x squared plus 3 will be equal to 19 over 4x. I'm going to multiply everything by 4, and that gets rid of all of the fractions in our equation. Always much nicer dealing with an equation without any fractions. And we're now at a point where we have a 3-term quadratic, so we need to equate it to 0 by subtracting 19x from both sides. I'm going to factorize the quadratic to find the solutions. Factorizes to 4x minus 3 and x minus 4, and so we can extract the two x solutions as x being 3/4 and x equals 4. We know that y is negative 3 over x, and so for each one of those values of x, you can work out the corresponding value of y. Fairly straightforward, and they come as pairs, so I'm going to put a little box around each one of them because those are pairs of solutions. Like so. Okay, question 17. We have ourselves, it's a circle, it's not a unit circle, but it's works on the same basis as a unit circle for sine and cosine, because we can construct a right angled triangle or inside it by dropping a line going from P to the x-axis. The x-coordinate of the point P will be the same as the adjacent to that on that right angle triangle. So cos of 60 will be that adjacent over 4. 4 is the radius of the circle because of the 16 in the equation. Cos of 60 is a half, so 4 times cos of 60 will give me 2 as the x-coordinate. The y-coordinate will be sine because it's the opposite. And so we've got 4 times sine of 60. Sine of 60 is root 3 over 2. 4 times root 3 over 2 is 2 root 3. And so this point P is going to have an x-coordinate of 2, a y-coordinate of 2 root 3. For part B, to work out the equation of the tangent to the circle at P, well, I'm going to first of all find the gradient of OP, that's the radius, because we know that the tangent to that point will be perpendicular to it. So the gradient OP will be 2 root 3 over 2, or just root 3. The gradient of the tangent will be the negative reciprocal, because it's perpendicular to it, if you prefer negative 1 over root 3. If you change that to negative root 3 over 3, that's fine. And then y minus y1 equals mx minus x1. x1 is 2, y1 is 2 root 3, m is negative 1 over root 3. Substituting those three values in and then expanding everything out. I've multiplied everything by root 3 here just to get rid of the fraction straight away. And then I've brought the x and the y terms onto the left and the non-x or y terms onto the right. So x plus root 3 lots of y will be equal to 8. You can, if you like, to finish this off by saying, therefore, clearly a is equal to root 3 and b is equal to 8. Question 18. We have a ratio of sides, r to s to s to c is 1 to 4. So that allows us to apply the sine rule here, but we can say, well, that this will also be true when r and s is 1 and s to t is 4. So although it gives us as a ratio, I can just call them 1 and 4 because the angle will be the same. The triangles will be similar, and it keeps everything simpler. So sine rule, sine theta over 1 will be sine 135 over 4. Sine of 135 is root 2 over 2. It's 45 degrees more than sine of 90. And so we get root 2 over 2 all over 4, which is root 2 over 8. Okay, question 19. So this one is completing the square. First thing I do is factorize out the 6. The observant amongst you will notice I have erroneously written plus 12. That should, of course, read plus 17. I have corrected it on the next line. You will all be relieved to know. Completing the square with the inside, so x minus 4x becomes x minus 2 squared, subtract 4. Expanding out the 6, so 6 lots of x minus 2 squared minus 24. Join those together, 6 lots of x minus 2 squared minus 7. Question 20, 3 stationary points. So stationary point will be when the gradient is 0, so we need to find the gradient of this curve. To find the gradient, I'm going to differentiating the curve 4x cubed minus 36x, equate dy by dx to 0 and solve to find the values of x. Factorize out to 4x, and then we've got difference of 2 squares, and we quite clearly have 3 different values of x here. We've got a 0 from the 4x part, and then negative 3 and positive 3. I've written them in ascending order of x. Maybe if you've got an idea about how a quartic works, that can kind of help you imagine what this is going to look like, and therefore the nature of the points. We sort of can mentally verify that we've got the right thing going on here. I'm going to carry out the second derivative test, so differentiate again to get the second derivative, d2y by dx squared, and then substituting the x coordinate of the stationary point into the second derivative. Well, when x is negative 3, the second derivative is 72. The important aspect of 72 is that it is positive, and that implies our stationary point is a minimum. Substituting x equals negative 3 into the original equation, we get y equals negative 81. And then do the same with x equals 0. The second derivative is negative 36, which is less than 0. That implies a maximum. Substituting 0 into the original equation gives us y equals 0. And lastly, when x is 3, the second derivative is 72 again, which is positive, and therefore we have a minimum. Substituting 3 into the original equation gives us y to be negative 81. And that's all the information we need. So our stationary points are going to be negative 3, negative 81, which is a minimum. It's going to be 0, 0, which is a maximum, and it's going to be 3, negative 81, which is a minimum. And that is how we would expect a quartic curve to look. If you've got a visual in your head, that should sound right. Okay, question 21, we've got a trig identity to prove. So trig identities, we will start with one side and work our way around to the other. So I'm going to start with the left-hand side of this identity. And the first thing I'm going to do, well, we've got 4 lots of cos squared x plus 3 lots of sine squared x. I'm going to give an extra sine squared x to the 3 sine squared x to make it 4 sine squared x, but then I'm going to subtract sine squared x at the end, because otherwise we'd be changing the whole expression. So what I've just written there all over cos squared is exactly the same as the line above. However, it allows me to factorise 4 out of the first 2 parts, giving me 4 lots of cos squared x plus sine squared x. And then we can subtract the 4 and subtract the sine squared x that we introduced just now. That's quite nice because cos squared x plus sine squared x is 1. So we've got 4 lots of 1, and then subtract the 4, subtract the sine squared x. And 4 lots of 1 subtract 4 is, of course, 0. So all we're left with in the numerator is minus sine squared x over cos squared x, which is negative tan squared x, which is what the question wanted us to end up with. Well done if you made it through all of that. All right, bye.